Hi, Margaret. I don't know if you have time to look at this before your test, but I was grading some net ionic equations today and just thought of a couple things to tell you at the last minute. When we were doing ammonia, it kind of caused problems because it actually does two different things that end up in the product. Like, let's say, for example, you put ammonia, a solution of ammonia, which is dissolved in water, and then you had a solution of, let's say, barium nitrate, and you saw a precipitate. Well, if I look at my solubility rules, would they help you do this problem? And there's a couple of things. First off, barium nitrate, like any nitrate salt, totally dissociates into cations and anions. Ammonia is weird because it's a base, and it's a weak base, so it does something that's not on the solubility chart, which is it dissociates to give some NH4 plus and OH minus. This is just a thing that's the definition of a base. A base accept protons until the leftover piece is OH minus. This is the thing that gives the precipitate, though. It's the barium from one of the test tubes, the barium plus 2, reacts with the hydroxide from the other test tube to give BaOH2 solid. So what the actual net ionic equation is can be written a couple of different ways. You could write the barium plus 2 hydroxides like that, or it could get a lot more complicated and you can kind of combine these reactions together. So I'm not sure what your teacher wants, but I think it's pretty safe to write this. Another problem that has to do with net ionic equations, which maybe the solubility rules won't help you with, is a net ionic equation that involves a strong acid and a strong base. So strong acids have an H out in front, and I don't know if your teacher has you memorize them, but this is what we do. We make them memorize 6 strong acids. That way, you know that each one of these totally dissociates in water to give H plus and then whatever the ion is. Strong bases give the cation and then the anions, OH minus. And here's where the chemistry happens. The OH minus reacts with H plus to give water. So the spectators do not appear in the overall reaction. The classic kind of net ionic equation involves using your solubility rules to see if you make something that has a solubility that is insoluble. So here, if I mix this aqueous solution and this aqueous solution, if I look at my solubility rules, I'll see that the new combination of this cation with this anion is a precipitate. And the net ionic equation then is just the cation from one plus the anion from the other gives my precipitate. Notice that the ammonium and the nitrate don't do anything because both of those salts are always soluble. One thing that's always tricky for students is when you have a weak acid as a possibility. Weak acids like acetic acid only partially dissociate. So even though they do produce water because of the OH minus and the H plus, you only have the one spectator. The acetate is written in the reaction, and here's the key. Whoops, my bad. Here's the key, because you don't break apart a weak acid when you're writing the net ionic equation. So notice that the sodium does not appear. Okay? If you have any other last-minute questions, I'd be happy to answer them. Bye-bye.